The seeds of inspiration to be an astronaut were planted early for all 7 crew members of Discovery. As a child, Commander Brian Duffy was fascinated by the launch of the first American in space.
The idea of being an astronaut was something that was planted when I was maybe in 3rd grade or so, about 8 years old. I was one of all those kids that sat in front of the black and white televisions and watched Alan Shepard launch. And you know, I thought a lot about, you know, my imagination would run wild, just like any child's imagination does, and I thought how great it would be to be able to do that.
After completing high school, Duffy turned his attention to serving his country and getting a chance to fly.
I applied to the Air Force Academy for college, was accepted to go there, and while I was there at the academy, I majored in mathematics, played baseball, had a good time, but probably the most important thing I did was I got a chance to fly in a number of different airplanes, one of them being the F-4. And to be a 19-year-old at the time in the back seat of an F-4, 100 feet off the ground going 600 miles an hour, made me realize that was something I really wanted to do.
While flying F-15 test flights at Eglin Air Force Base, Duffy took notice of an announcement from NASA.
The call for applications went out, and they were looking for people to apply for the shuttle, and I was surprised to find out, quite frankly, that I had qualified, filled all of the squares that you needed to fill to be competitive to apply. And I thought, you know, I couldn't let that 8-year-old kid from so many years ago down to find out that I was qualified to apply and not do it. You know, would I be able to live with myself? So I applied, and very, very fortunate to be here.
Duffy was the pilot on 2 shuttle missions and served as commander on a satellite retrieval mission. Pilot Pam Melroy decided to do something special with her life after she witnessed the first lunar landing.
I was definitely very inspired by the Apollo program, especially Apollo 11, the first landing on the moon. I really remember that. I mean, that was a big event in my family. We were on vacation, and I remember us all crowded around the television set watching it. My father was actually taping it, which is a pretty big deal at the time, and we kept the tape, and it really had a big impact on me. I was a pretty serious little kid, you know, and I just felt like I wanted to do something important with my life, and this seemed like the most important thing anybody could do, something that was for the good of everyone.
Melroy had chosen a career without knowing if it would even be possible.
I was very fortunate at the time that I had decided I wanted to be an astronaut. Women were not even allowed to be military pilots. But I was born at the right time, and the doors just opened a few years ahead of every step that I made, and so I was really lucky. While I was in high school, they started letting women fly in the military, and so after I graduated from college, I got a master's degree from MIT, and then I went to pilot training. And I flew the KC-10, the military version of the DC-10, for several years, and then was selected for the Air Force Test Pilot School and became a test pilot. And that was the steps that it took, and it's prepared me very well, I think, to be a pilot astronaut.
STS-92 is Melroy's first trip to space. She becomes the 3rd female shuttle pilot, following Eileen Collins and Susan Kilrain. Man's landing on the moon also fascinated mission specialist Leroy Chow.
I remember being in my parents' home, a hot summer day, watching Neil Armstrong and Buzz Aldrin touch down on the moon, and then later that evening actually take the first steps on the moon. And to me, that was really a big event. And, you know, most kids, or a lot of kids, come away with the idea they want to be an astronaut. But it's something that stayed in the back of my mind all the way through college when I was studying engineering. When I realized I really could do this. I received my bachelor's degree from the University of California at Berkeley, and then went on to University of California at Santa Barbara to receive my master's and doctorate degrees, also in chemical engineering. I then started work at Hexcel Corporation in the Bay Area, in San Francisco Bay Area, which is a composite materials supplier, and moved on to the Lawrence Livermore National Laboratory, where I was doing some research work. And I applied to NASA and was invited down to an interview in September of '89, and was fortunate enough to be selected in the class of '90.
This flight is Chow's 3rd space shuttle flight. Mission specialist Bill MacArthur has had a lifetime fascination with science and technology.
I was almost 10 years old when the first human beings went into space. And as a youngster, I grew up with an interest in all things technical, an avid science fiction fan. But I never really had any idea that I could actually go into space. I was interested in joining the Army, and so went to West Point, the United States Military Academy, and was commissioned lieutenant and did the things that lieutenants could do. I was interested in flying, so I asked the Army to send me to flight school, and they did. In college, I'd really gotten fascinated with engineering and liked aircraft, liked rockets, engineering, kind of put it all together, and aerospace engineering made a lot of sense.
As his career progressed, MacArthur looked for ways to expand on his interests. The space shuttle program seemed like the next logical step.
It looked like it would combine the two things that I really liked from a professional standpoint, flying and engineering, and was really the pinnacle. It seemed like it's the apex. I mean, the highest professional success you could achieve in those combined fields.
MacArthur is a veteran of 2 previous space flights, one to the Russian space station Mir. Like many of his crewmates, NASA's Apollo program also inspired mission specialist Jeff Weisoff.
I was growing up in Virginia when the men walked on the moon for the first time, and I remember watching that live on TV and being very excited about it, and always thinking that would be a great thing to do.
Weisoff pursued an interest in science and kept up with NASA as his career progressed.
I went to college at the University of Virginia and majored in physics there. And then I went on to Stanford University and did my degrees in applied physics and laser construction technology. And then I went to Rice University, where I was a faculty member there before being selected to NASA.
Weisoff has flown on 3 previous shuttle flights, also having boarded the Mir space station. Space was one of many interests for Mike Lopez Alegria as he grew up in Madrid, Spain, and Mission Viejo, California.
When I was a kid, a young kid, I wanted to be an astronaut, probably like a lot of young kids, but I changed my mind many times. You know, that was about when I was 5. And I thought about it again when I was 25. I was reading an article in a magazine about Naval Test Pilot School, which is something I had just become interested in, and there was a sidebar that talked about graduates from that school who had gone on to become astronauts. And I think that's kind of what gave me the idea that, hey, maybe I could do this again.
While working to achieve his goal of becoming an astronaut, Lopez Alegria took a different path from other test pilots.
I went to the Naval Academy, engineering degree, pilot training, test pilot school after getting a graduate degree, and a couple of years as a test pilot, and then got picked up to come here. A little bit unusual in that within that sort of typical Navy mold, I was not in a tactical jet squadron. I was in a heavy propeller reconnaissance squadron, so there aren't very many people, in fact there are no people out of my particular aviation community that have either gone to test pilot school or come to NASA.
Lopez Alegria previously flew in space on STS-73 in 1995 and recently served as NASA's Director of Operations at the Gagarin Cosmonaut Training Center in Russia, responsible for astronaut training for the International Space Station. As a child, mission specialist Koichi Wakata wanted to travel to space. But as a citizen of Japan, he never imagined it would be possible.
For me, being Japanese, going to space was something like an impossible dream to achieve. And now, 30 years later, I'm very happy, I'm very fortunate to be part of the team here to participate in the human space program.
Before his dream was fully realized, Wakata followed his interest in flying.
And I also was in a team at the college participating in competitions of building and flying human or piloted gliders. And that's why I wanted to study aeronautical engineering, and I study that subject as an undergraduate and graduate in Japan. After graduation, I worked for Japan Airlines as an aeronautical structural engineer before I became an astronaut.
This is Wakata's second space shuttle flight. Wakata, Chow, and Duffy all flew together previously on STS-72. An experience for which the commander is grateful.
knowing Koichi and Leroy as well as I do from our last training flow, and also the flight before that I flew with Jeff Weissoff. So knowing half my crew as if they're my brothers already certainly makes it a lot easier. When you're training together for this long and you're this close together, you become like a family. You become very close. And I'm actually not looking forward to the day when I don't get to see them all every day.
The Z1 truss and the pressurized mating adapter are both key components for the continuing expansion and on-orbit construction of the International Space Station, enhancing its capabilities and providing a backbone for further installation during subsequent assembly missions. For a bit of an overview of the capabilities of those two components and how they will be installed on the International Space Station during 4 scheduled spacewalks with the use of the shuttle's robot arm operated by NASA astronaut Koichi Wakata. We're going to run a short video piece with an overview of pressurized mating adapter 3 and the Z1 truss.
Discovery is carrying 2 major additions to the International Space Station: the Z1 integrated truss structure and a second shuttle docking port. The Z1 truss is a unique piece of hardware that is crucial to the continuing construction of the space station.
It's important because it becomes the base that all the solar platforms are built on. We put it on the zenith port of the node, the top port of the node, and we'll have it there, and then the follow-on flight, 4A, with Brent Jett and his crew, they will add the solar array on top of that. So this is an important base.
And what the Z1 is, it's kind of a foundation or a conduit which the power is going to flow through and supply all the, it's a necessary interface to bring the power from the solar arrays into the space station.
The Z1 truss also serves as a platform for early communication on the station.
And on the Z1 truss is a number of pieces of hardware. There are some antennas that will be used later to give the station a larger amount of communication capability than it currently has. And during our EVAs, we actually move those antennas around so that they can be positioned correctly later and actually be put to use.
On the S-band antenna, we're merely kind of ferrying it up there. We're going to relocate it out of the way, out of its launch location, and then the next flight's going to pick it up and put it up on the P6 truss in its final location. So that's not really active during our mission. We're going to go ahead and deploy a KU boom antenna and get some power to it to keep the heaters on it to keep it warm and alive. But that will eventually be a big broadband antenna to send TV images and back and forth to the ground.
The Z1 truss also houses a gyroscope system that eventually will serve to significantly reduce the use of thrusters and propellant to maintain the station's orientation.
It also has on it control moment gyros, which are basically like big spinning tops that help maintain the attitude of the station, keeps the pointing in the right direction without burning fuel, liquid fuel that we have on board the station. It also has what are called ammonia accumulators on it, which is part of the thermal system that helps cool the station once it's all put together.
Many of the functions of the Z1 truss will be taken over by new systems as the space station grows.
I would consider it like when you go to a new construction site, they build a small building, which is where they start running all the operations out of, and they put in telephone lines and air conditioning. And then once the building is done, the construction site is done, that building is all not really that important anymore, but you can't really go anywhere without it in the beginning.
The other major piece of hardware the crew is bringing is pressurized mating adapter 3. PMA-3 will give the station greater flexibility for dockings as the station grows.
We're also bringing up what I like to call the side door to the station. because of the assembly sequence, it's not always possible to dock the shuttle to the same location and actually successfully attach pieces. You have to have some flexibility. And so we're bringing up that extra flexibility.
Well, the PMAs are our equivalent of the terminal gate at an airport. PMA 2 is where the shuttle, where our flight and where all the shuttle flights that have gone up to the station, up through ours, will dock with the International Space Station. Well, you know, sometimes maybe gate 20 isn't available, so you have to go to gate 21. So that's what PMA 3 is. It's essentially the next gate to which arriving and departing shuttle flights will be able to attach.
And that allows the next flight after us to dock to that docking port in order to be in the correct position to put its hardware on top of the Z1 truss, which is going to be the solar arrays that they're going to put up there.